Hello. Okay, so we are still in the Advanced Object-Oriented Programming chapter, and we're going to work through the 4 files here on inheritance. So inheritance is this third design pattern that we want to know where we have 2 different classes interacting. The point of this is that you have a child class inherit variables and methods from a parent class, just like we all have parents and we got aspects of our DNA from them, directly from them, right? You can have 2 different classes and have a child class that inherits the methods and attributes from its parent class, essentially. But you can customize parts of it as well to make it different. So you can read through this on your own time, but just to kind of quickly summarize like what the entire point of this is, and mostly it's so you can reuse code. So like if you, let's say you wanted to have 2 really similar but different classes, rather than rewrite like, let's say the 2 different classes would share 90% of the same code, rather than rewrite that same code twice, you can just write one class and then have 2 separate classes inherit from it, and then just customize where it differs, but other than that, you're just sharing the same code. That way, if you ever have to change that or update it, you just have one place where you're going to update it, right? So we have parent classes. You can also call that a superclass. And we have the child class. You can also call that a subclass, okay? So I'm going to go over all these points just when we write it out. So I'm just going to skip down here and start actually writing out the practice problem here. So we're going to illustrate this with an employee and a manager. So a manager is like a specific type of employee, but with more specific things that it can do. So what we're going to do is we're going to write in an employee class, and this is going to be the parent. And after we do this, we're going to write a manager class. So let's just start with this. So we give some outline of what we want here. So let's just say class employee. Let's see, we have a class variable for company name equals, let's just say this is the IO303 company. Let's define our initializer. Let's say we have name and salary. Name, salary. Okay, say self.name equals name. Self.salary equals salary. So the methods, you have structure, get status, returns their name and salary. Okay, let's do this. I like having space between everything, so let's do that. Get status, let's just do self. Let's return a string that says self.name has a salary of self.salary. And why don't we make it formatted a little bit nice? Let's do that. Give it a period. Okay, so that's just going to return a string, and then we also want one for give a raise. So we have self, and then we want to pass in some amount to give a raise to. So increase their salary by a passed in amount. If a raise over 20K is given, limit the raise amount to just 20K. Sure, okay. So let's say if amount is greater than 20,000, then we want to give them a raise to their salary of just 20,000. Okay. Otherwise, let's just say that their salary gets increased by the amount directly. Oops, amount. Okay. Create an employee object and run get status and give raise. So let's create our employee here. Let's say I'm just gonna call him employee 1, and employee 1 is John with a salary of 100K. Okay. So let's print out employee 1 dot what do I call this? Get status. Let's do that one. Oh, I need to actually make sure this is an employee. I forgot the key part of that. And then let's see, what else do we want? Let's give him a raise. Employee 1 dot give raise. Let's give him a $10,000 raise. Then let's make sure that we did that correctly, and just we should see a $10,000 increase there. Okay. So cool, sweet. Let's add even. Is it commas? No, it's commas first. There we go. Just to make this print out a little bit nicer. There we go. Cool. In fact, we probably don't even need to round. Let's just do that. Yeah, that looks plenty nice. So John has a salary of 100,000, but we give him a 10K raise. Now it's 110,000. Cool. So let's now, we haven't done any inheritance yet. We're just starting out with a parent class that a child is eventually going to inherit from. Okay. So now let's go to part 2.1. So we want to write a manager class that inherits from employee. Just put past the line after class and don't put anything else in the class. Then create a manager object. Try and access a variable or method from employee. So what we're going to do here, and I'm just going to put it right here. That way our code is relatively close together. Let's just say class manager. And if we want something to inherit from another class, so we have our class employee right here, right? We just want to inherit from it. So we put that inside of parentheses right here, okay? Then afterwards, we can add any extra stuff that we want managers to have, but I'm just gonna do pass, which does literally nothing. The reason I'm doing that is because if I had any other code here, like a variable, right? So this is valid code. If I didn't have pass here, then this is expecting some kind of code here, so that violates this rule. So just by putting pass, I follow Python syntax by having some line of code after a colon, but I'm literally doing nothing here. So let's just do that and let's create a manager. Let's say manager1 equals Jess. She's a manager, so let's say she's making more, 180,000. Cool. Okay, so I've put nothing into this class, but because I'm inheriting from employee, I automatically am going to get everything that an employee has, okay? So let's say I want to see what, let's do manager1 dot get status. Let me set a breakpoint here, and let's step into this so we can see what's happening. So I'm going to try and create a manager. So it's going to come up to manager, but there's nothing here. There's no constructor inside of manager. So then it's going to check where I'm inheriting from, and it's going to jump back up to here, okay? So let me step into this line of code, and we can see what goes on there. And there we go. I jumped up to the employee initializer, and I'm going to give a name and a salary, okay? And what I get back is a manager object, but it just has everything from employee because we inherited from it, okay? So we can get the status. We say Jess has a salary of 180K, okay? So we're going to start there, and then let's come down here to 2.1. And okay, that's what we just did actually. Let's go to 2.2. The manager class, add a method that only exists with the manager called givePraise. Put a parameter in for an employee object. The method should just return a string that says, "You're doing great, employee name." Create a manager object and call givePraise, okay? So let's come into here, and instead of just pass, let's write a function and call it givePraise. We're gonna have self, and then we're gonna have an employee object, okay? All we're going to return is a string that says, "You're doing great, employee object dot name." Okay. So now as a manager, my manager1 can give praise to employee1 like this. this out. So if I run that, I can now see you're doing great, John. Okay. So what we've done is we've just added an extra method that only exists for managers. I can't do, it wouldn't work if I tried to say, hey, employee one, the one that we created up here, they do have a get status, right? But they have no give praise. They have give raise because that was defined here, right? But give praise was only defined for managers, so I don't have access to that functionality for employees. But managers are like more specific types of employees, so they can have customized functionality. So they have everything else, like give raise, but we also get give praise, okay? So you can add entirely new methods, like what we're doing here. We could also come down and we can override existing methods. So let's say in the manager class, add a method called giveRaise, the same name as the method in the employee class. However, managers get a 10% bonus to whatever raise is given to them, but they are still subject to the 20K cutoff. Discuss using this method without super and with super. So we'll get to this last part once we show a couple of examples. So I'm going to come over here and I'm going to write another method, but I'm going to call it giveRaise. Okay, you can see I pushed enter and actually gave me some of this starter code. I can see it gave me the same parameter as what exists up here, and it also gave me the super code. I'm going to come back to this though. Okay, I'm just going to delete that for now. And what I'm going to do actually is just copy and paste the exact code here. And what I'm going to do is just the same thing that we have here, except let's see, what did I say to do? Give it a 10% bonus. Okay. Okay, but it's still subject to the 20K cutoff. Okay, so let's do, where are we? Right here. So I could just say, hey, you know what? Amount, because they are a manager, is going to equal amount times 1.1 for a 10% raise, right? That way, let's say I want to give now, I want my manager to get a raise, and I'm going to give them, just to be real simple, let's just give them $1,000 raise, so a 10% of that would be 100. And let's see what happens when we do that, okay? And we will also get the status, so we can see what the raise was afterwards. Set a breakpoint there. So before, when I said, hey, manager, in fact, let me go to get status, right? So if I do get status, that get status method doesn't exist inside the manager class, but it does exist inside of employee, right? So with get status, if I step into it, I go to that version. I go to that method because it only exists in employee and I'm inheriting from employee, okay? So I can run that and it prints it out just fine. Okay, so this is Jess has a salary of $180,000. Okay, give praise only exists in manager, so it goes there. If I were to step into it, it works just fine to do that. But now I'm doing give raise, and I have give raise in both the inherited class, or the child class, I should say. I have give raise, and then in the parent class, I also have give raise. So first, it's going to check its own class. This is a manager object, so first it's going to check manager. If there's a method with the same name, it's going to do this version of it. So if I step in on this line of code, I'm going to jump up to here. We have give raise, okay? And it's running this version of it. So I'm giving a 10% raise, right? So I'm still not letting him do a raise over 20K. But otherwise, I'm basically multiplying that by a 10% raise. So what I get afterwards is bigger than it would have been had they been a normal employee, right? So this is this is called overriding. So here we're overriding the original employee give raise method, right? So when managers run it, it goes to this version. So we talked at the beginning when we were doing this that there might be a different way you could do that by using super. So I'm going to, let's talk about kind of the philosophy behind this. If I look at this method, and then I also look at this method, do you see how like almost all of the code is really similar? The only different part is this line right here, right? So rather than retype out all of this code that already exists here, this is generally considered bad practice to just have code repeating that's basically identical, right? Because let's say I wanted to change the logic of this. Let's say I wanted to instead put the limit at 30,000 and I wanted to change this. Now I have to change it 2 spots. And if I don't remember to change it in both of those spots, then my program is going to have a bug in it. It's going to have a logical bug, right? So let's just put it back how it was. Instead of repeating it though, I could just do this. Get rid of the code that's repeating. We still have the code that is the same, or that's unique to managers. And then we say, hey, you know what? Super.giveRaise. Oops. Sorry there. Give raise. And we are going to pass in the amount. Okay. So super is referring to whatever class we're inheriting from. So let me actually step into and run the same thing that we just did on this line. Okay. Let's set a breakpoint there. I'm going to step into it. I'm doing give raise. And I then know that my amount, I want to give it a 10% raise. Okay, so I'm going to shift what my amount is, okay, to 1,100. And then I'm going to call the super version of give raise, which is just the original version. So let me step into that. So now I'm doing the original version logic, but now I've basically I've done a change to this value that this parameter has now. So I don't have to repeat my code, but I get that extra functionality with only writing one extra new line of code and then just calling the original version, right? This is just a more elegant way of coding. Sometimes you can go overboard, and sometimes it's easier to just repeat something and make the change there. But in general, you should think of ways that you can write code in a more elegant way that allows you to not repeat yourself, essentially. So on any test in my class, if you're watching this as my student, you could get full credit doing it either way. You could have written it this way, right here, if I uncomment that. You could write it this way and you get full credit. You could write it this way, you can get full credit. I just think it's worth thinking about if you could do something like this, because I think in general that's a better way of doing that. So let's do that, and let's see if we have anything else on here. Yeah, we need to override the constructor. So let's override the constructor in the manager class. Make it so that managers have an instance variable for department, describing which department they are over. Use super to access all the other instance variables, okay? So far, we have been passing in a name and salary for our manager, right? And we don't have any constructor already inside of our manager class. And in fact, I'm just going to delete this just to save space. So we can just look at everything right here. But what if I did add a constructor? What if I did a init self name salary, and we also want to add a department so we can see what department they're over. Then I was already getting name and salary before, right? So you might think that I could just say, hey, self.department. Oh, and let's make sure we spell it correctly. Equals department. Okay. Let's say Jess is over the HR department. So if I were to set a breakpoint and we look into here, we step in, because I now have an init function here, I'm going to run this one and only this one. I'm not going to actually run this original init here. So what you're going to see actually is that my manager only got the this instance variable. They only got HR. They also got the class variable still, but because we didn't actually assign the name and salary, we're missing that even though we got it before. So we could do something like this, say self.name equals name, and then self.salary equals salary, and that works totally fine. But just like we said before, why repeat yourself if you already have this code already all written out? So let's do self.init and pass in the name and salary. And that's going to call the original version of init here. It's going to do all its work here, then finish and come back up over here. Okay, so let's restart our code, run it again, step into it. So now we have our name and salary that we've passed in, but we're going to call the original constructor here and pass in just the name and salary, the only ones that apply to the original employee. Let's step into that. So now we're here. We're going to assign name and salary to our object, which is still a manager object. Okay, so we're getting the name and salary. And then afterwards, we can add the manager specific variables here, right? So like department. So now our manager has all of them. It has name, salary, as well as department. And maybe you might want to update, get status or something like that to include the manager name, so we could override that. But we've already done an example of overriding, so I might not do that here. But hopefully that gives you a good idea of what we can do with inheritance. So we're going to do a few more practices of that. I'll probably split each one of these up into their own file because I think inheritance is a little bit longer of a concept. So I'll end the file here, or end the recording here. We'll do another recording for inheritance practice, and then probably another one for the second one as well. So we'll see you there.